Now we're going to begin solving equations that involve powers. And as you might suspect, if we start with a power, then to undo that we use a root. For odd powers, you can directly use the base of the power. But for even powers, you have to take into account that there's going to be two real numbers that work, a positive one and a negative one. So if your original power is even, like x squared or x to the fourth or x to the sixth, then you have to include this, what people often call a plus minus symbol. It's really more of an idea of being positive or negative. So as an example, if I found the fourth root of y to the fourth, I would have a positive value and a negative value. Again, why is it working? Well, it's just the inverse of the idea we used with roots. That is, I can think of this root in terms of rational exponents, and then by the power property I can multiply 4 and a fourth and I'll get 1. And if my base is x and my exponent is 1, I can just replace that with x. So I'll do this first one. Since my exponent is even, I have to remember that when I take the square root of both expressions to include a positive and negative idea with that right-hand value. On the left, the square root of x squared will be x. And then we have to remember that the square root of 12 isn't considered simplified. And so we're going to have to think of this as 4 times 3, which will give us 2 times the square root of 3. Now, this implies my solution set is going to have two elements in it. It's going to have negative 2 roots of 3, that's right here, and it's going to have positive 2 roots of 3, and that's what this is getting at right here. I'm not going to check both of them, I'm just going to check one of them. I think I'll check this one. And by the power of a product rule, I can square the negative 2, I can square the square root of 3. This is going to give me 4, this is going to give me 3. The product's going to be 12. It's a match. And so I'm confident that both my answers are solutions. Here's one for you. Since I have an exponent of 5, I'm going to have an index of 5. That is, I'll take the fifth root of both expressions. Over on the left, the fifth root of x to the fifth will simply be x. And on the right, I can't simplify this any further. Now, to check my work, I'm going to return to the original. I'm going to substitute my answer into parentheses. And then the fifth root of negative 14 can be written this way. And of course, we can multiply by the power rule and get negative 14 with an exponent of 1, which is a match. How about here? Since my exponent's a 6, I want an index of 6 when I take the root of both sides. Because I have an even exponent, I'll need to include both of my answers. I'll simplify and then check. Again, I'm just going to check one of the two. The dash symbol is going to be a factor of negative 1. And then by the power of a product property, I'm going to find the sixth power of negative 1, which is positive 1. And then I'm going to find the sixth power of the sixth root of 11, which will just be 11. And since my values match, I know both of my answers are solutions. Here's the last one. My exponent's a 3, and so I'm going to want my index to be a 3. I'm going to take the cube root of both sides. On the right, I'll simplify to x. And then on the left, I have to try to find perfect cubes as factors of 54. And if you prime factor, you'll see that 54 is 27 times 2. And then the cube root of 27 is 3, so I'll get a 3 outside and the cube root of 2 as the other factor. As always, please check, and again in this case you'll be using the power of a product rule. Well, that will conclude this video where we've begun to solve equations that involve powers.